Welcome! This is the homework solution for the sequence 1.8 Ready, Set, Go. What we have here is the ready. Find the common ratio for each geometric sequence. Here I have the common ratio as 2. How do I get the common ratio as 2? Here's the work. It's n divided by n minus 1. So I use the term 2. 2 was the second term, and I divide that by the previous term, which was 2. Right? 4 divided by 2 gets me 2. Likewise, I could also have done it as 8 divided by 4. Either way, it should have still get me the same answer. Alright? Next, the common ratio here is also 2. How did I do that? Here, it's n divided by n minus 1. So, I just use 2 divided by 1. Gets me 2. Or, I could have just done 8 divided by 4. Again, still gets me 2, right? It goes from 1/2 to 1 to 2 to 4 to 8, right? It's always multiplying by that common ratio of 2. Next, -5, 10, -20, and 40. Here, the common ratio is -2. How did I do that? Again, it's 10 divided by -5, which is equal to -2. Likewise, I could have done -20 divided by 10. Also equals to -2. It's going for each term to the next by multiplying by -2. 4. You are multiplying by the common ratio of 1/2. Right? How do I get 1/2? It's n divided by n minus 1. In our case, I use 5 divided by 10, which is equal to 1/2, or in decimal form, 0.5. So, what is half of 10? 5. What is half of 5? 2.5, and so on and so on. Next, this is the set part. Fill in the blank for each table, then write the recursive and explicit equation for each sequence. I don't know if it's arithmetic or geometric. In this case, I'm going to see both, right? So from 5 to 7 to 9, it looks like it's going up by 2. So here I could say that the common difference would be that it is adding by 2. That is correct, right? I'm looking to add by 2 to each term, right? And if I'm going to look for my first term, I would say my first term is equal to 5. Do you see how my first term here is equal to 5? Alright, so here is both the recursive and the explicit, right? What do I plug in for my common difference? 2. Then I leave it like that. That's perfect. That would be the recursive equation. Explicit. What do I plug in for f of 1? I plug in the value of 5. What do I plug in for the common difference? 2. There you go. I am completely done. If you would like to see this in y equals mx plus b format, it would look like this. Y is equal to 2x, and that is going to be plus 3. Okay? Because this, let's see, insert table to the left, the 0 value here would be 3. That is how I get the y equals mx plus b format. Alright, good. Next one, going from -2 to -4 to -6. It seems like I am adding a value of -2. Right? So that is my common difference. Again, this is going to be arithmetic because it's going up to each term by adding the common difference of -2. Right. I also want to find my first term. My first term here looks like it is -2. Right? So I have the recursive equation here, then I have the explicit equation here. Right? What do I plug in for D? -2 is the common difference. I'm all done there at the recursive. What is the explicit? I plug in the first term here. The first term here is going to be -2, and I get that off my chart. And D, which is the common difference, which is going to be -2, right? So this looks really weird. It looks like it's a subtract 2, so make sure you put the parentheses out here, all right? There you go. You also might see it this way, where they put the -2 out here, right? So you might also see it like this. That works as well, okay? Or, let's see, the 0 term here would be, looks like it would be 0, right? It's going -2 each time. Yep. So if you would like to see this in y equals mx plus b format, y is equal to negative 2x plus 0. Right? That's what it would look like in y equals mx plus b format, which is the explicit. All right. Next, 7. All right, let's look at 7. 7. It goes from 3 to 9, 27, 28, 81 to 43. It is going up very large, right? I determined that the geometric it's geometric because it's going up really fast, and I found the common ratio. The common ratio here is 3. All right. So what do? I plug it into the recursive. It becomes 3 times the previous term, and the explicit. Right? The first term, which is 3, times the common ratio, which is 3, to the n minus 1 power. So that's how it would look like. Right? Good. Let's bring up 8. 8. Here's the table: 27, 9, 3, 1, 1/3. It seems like it's going down really, really fast. Okay. Here you could have done the common ratio of 9 divided by 27. Or if you just see the 1 and the 1/3, right? It helps you really out. How do you go from 1 to 1/3? Common ratio of 1/3. Very easy once you have that one term. Okay, so plug it into the recursive again. The common ratio is 1/3. You times that by the previous function. That is the recursive formula. And the explicit formula is going to be 27, which is the first term, times the common ratio of 1/3 to the power of n minus 1. Next, we have the go part. Write each equation of the line in y equals mx plus b form. Right? Name the value of m and b. Just to let you know that m stands for the slope or the rate of change, as well as the y-intercept being the b value. Alright, so I have this image right here. I'm going to grab that image into Paint. Alright, hopefully we could see it in Paint. Can you see it in Paint? Yeah, alright. Alright, you should see it in Paint now. Okay, so let's find the value of slope first. Let's do that. I go from here to this dot, right? Because that is where it intersects the line, right? So it goes up 1, 2, 3. So this is a plus 3 in that is my change of y. Okay, oop. That's a little bit bad. Change of y. Okay, and let's do my x. Right? So change of x is equal to also plus 1. There you go. Good. What is my y-intercept? I'm going to make that green. It looks like this is crossing it right there. So that is at the point 0, 2. Or you could say that the b is equal to 2. Alright. So we'll make sure I grab this image so you can use it right here. Alright, there you go. Make that a little bit smaller. You would say that slope here would be equal to 3 over 1. The y-intercept here would be equal to 2. Plug that into the equation of 3 over 1. And the y-intercept here is 2. There you go. Next one. Again, we are going to grab that into Paint so we can work with it. Let's find my slope. So it goes from here. Goes from here to there. Wow. Seems like it's going down a lot. Alright, so looks like, how much is it going down? 1, 2, 3, 4. Whoa, negative 4. Right? And how much is it going in the right direction? Okay. This is plus 1. So we would say the change of x is equal to plus 1. Likewise, you want to say that the change of y is equal to negative 4. Alright, let's look at the y-intercept now. The y-intercept here is at this dot, so which is going to be 0, negative 1. So the b value here is going to be equal to negative 1. Okay, there you go. I'm going to grab that image so we can use that. What is the slope here? It is 1/2. No, wait. Looks like it's 4 over 1. Likewise, the y-intercept here looks like it is -1 because it is crossing over -1. So you plug this into the equation. The m is the 4 over 1, which is the slope, and the y-intercept here is -1. Okay? There you go. That was how the equation would look like in y equals mx plus b format. Again, oops, this is wrong. Haha. Look at this. This is supposed to be a negative because it's going down. -4. This would have been a -4, right? So this is a -4. Makes sense because it's a negative downward slope. Good? Alright, let's look at 11. Here I did the work for you because I already explained it in detail for number 9 and 10. Here, number 11, right here, I have the slope here as 3 over 5, the y-intercept as -3. The equation would be y equals 3 over 5x minus 3. 12, the slope here is -1/2. Again, it is going downwards. I simplify it from -4 over 8. The y-intercept here is b equals to 4. The equation would be y equals to -1/2 x plus 4. And there you go. That is all the homework solutions for this section of 1.8.